Assalamualaikum everyone. In this video, we are going to learn about optical device and combination of lens. Optical device are the devices that help us to get clear view image. There are so many devices that use lens and mirror, but today we are going to learn about three types of device. First, magnifying glass, microscope and telescope. The first one is magnifying glass. So we use convex lens, and this is the example of the ray diagram. When we use magnifying glass, the image must be at or within the focal length of the lens. Then our image will produce as upright, magnified and virtual, as shown in this ray diagram. Second one is compound microscope. This is the basic microscope which consists of two convex lenses, and it will produce a magnified, real and inverted image. There are two types of lens. The first one is objective lens, which is situated near the object, and also eyepiece lens, which is situated near to the eye of the viewer. So this is the example of the ray diagram. The object is situated here, and it will refract through this first lens to produce the first image, initial image. After that, this initial image will be the second object for this eyepiece lens or this second lens to produce the final image. The third device is telescope. We use telescope to see distant object or object that is very far away. So there are two types of basic telescope. The first one is combination of convex and concave lens that will produce final image right here. When we use two convex lens as the telescope and the object is very far away, it will produce the first image right here, then it will refract again at the second lens to produce final image. Based on the previous slide, we all know that microscope and telescope are the example of combination of lens and mirror because they use more than one lens. So for the combination of lens and mirror, we will apply law of reflection and also law of refraction, spherical mirror equation and also thin lens equation to solve this combination. Okay, so this one is about total linear magnification. When we have two or more lens or mirror, so to find the total magnification, so this is the equation, V1 over U1 times V2 over U2. Since we use this modulus, thus our answer will always positive. We will determine the magnification as either final image is magnified, diminish or same size. Let's do this example 1.17. There are two biconvex lenses A and B are placed 20 cm apart as shown in figure below. Okay, 20 cm apart. If lens A has a focal length of 10 cm, I label it as FA. Since this is a convex lens, so convex lens, the focal length is positive 10 cm, and for focal length for lens B is also positive 20 cm. An object is placed at a distance of 30 cm from lens A. This is the object, and object distance U is equal to positive 30 cm because this is real object. We put it in front of lens A. To solve for this equation, you cannot solve it together. Kena selesaikan one by one. So let's start with lens A first. Lens A. Apply thin lens equation. 1 over F equal to 1 over U plus 1 over V. Substitute the focal length U. Then you will get positive 15 cm. From this value, positive V for lens is real image and form opposite side with object. So where will be the first image formed? Let's label on this diagram. real and form opposite side with object. So image will form at this side with distance from the lens 15 centimeter. So first image will form here. This first image will be the second object for lens B. So let's do this. Lens B. Apply thin lens equation. 1 over f equal to 1 over u plus 1 over v. So f for lens B is positive 20. U. What is the value for u? You need to measure from this object 2 or the first image from the lens B. So 20 minus 15, then you get 5 centimeter. Since this object is situated in front of this lens B, so it will be real object, positive 5. Then your V will be equal to negative 6.67 centimeter. What does it mean by this negative 6.67 centimeter? Negative means the image is virtual and also formed at the same side with object. What will be the final image? So same side with object means that it will form at this position with distance of 6.67 centimeters. So final image will form here. For question B, find the overall magnification. So total magnification equal to modulus V1 over U1 times modulus V2 over U2 equal to V1 for the lens A, 15 divided with 30 times with V2 for lens B, 6.67 over 5, 0.67. So the magnification is less than 1. Final image is diminished. Example 1.18. We have a combination of a convex lens with focal length of 20 centimeter. Right, so here is the convex lens. Placed coaxially with a convex mirror. Here we have convex mirror of radius of curvature 20 centimeter. The two are kept 15 centimeter apart from each other. And object is placed 60 centimeter in front of the. Okay, this one is typo. It should be convex lens. Okay. So from the information given, we know that this focal length for convex lens is positive 20 centimeter. The focal length for mirror, we have the radius of curvature 20 centimeter. So focal length, just divide it with 2. But for convex mirror, focal length will be negative. So it will be negative 10 centimeter. The distance between them is 15 centimeter. So let's use thin lens equation for lens A. Substitute the value for F. U is 60 centimeter. Then VU will get positive 30 centimeter. Positive means the image is real and form opposite side with object. Now where is the first image formed? So 30 centimeter and opposite side. So kalau opposite side, it should be here. 30 centimeter from the first lens. This will be the first image and also it will be the second object for this mirror. Now let's do the equation for mirror. Mirror B. Spherical mirror equation. 1 over F equal to 1 over U plus 1 over V. Focal length is negative 10. What about U? So for U, or object distance, we need to measure this object from the center of the mirror. So we will get 30 minus 15, 15 centimeter. But we need to check whether it's real object or virtual object. Okay, so how to know if the object is behind the mirror or behind the lens? Thus it will be virtual object, and we put it as negative 15 centimeter plus 1 over v, then v we will get negative 30 centimeter. So negative for mirror means that the image is virtual and from opposite side with object. Please refer the sign convention table for mirror. Do not confuse with sign convention for lens. Alright, so where will be the final image? Since this is the object, image will form opposite side. So kat kawasan ini with a distance of 30 cm from the mirror. So image will form at this point. Final image right here. For the overall magnification, substitute V1 over U1 times with V2 over U2. V1 is for lens 1 30, U1 is 60, times with V2 30, divide with 15. So the answer is 1, shows that the final image is same size with the object. So for the summary for this chapter is about geometrical optics, and it has first subtopic reflection. In this reflection, we have learned about the law of reflection, plane mirror, spherical mirror, the spherical mirror equation, linear magnification, and also ray diagram. For refraction, we have learned about law of refraction, refraction at a plane surface, and also refraction at spherical surface. For refraction at plane surface, we can apply the Snell's law equation. And for refraction at spherical surface, we can apply this spherical refracting surface equation. And for thin lens, we've learned about the ray diagram for concave and convex lens, lens maker equation, thin lens equation, and also linear magnification. And last one, we have learned about optical device. So in optical device, we have learned 3 types of device: magnifying glass, microscope, and telescope. It's about combination of lens and mirror, and also total magnification. So that's all for chapter 1. All the best for your test. So next week we are going to learn about physical optics.